Welcome to my Friday Swift Code Challenge. This challenge is part of a series designed to help you learn and practice Swift programming. The rules are simple. I'll post a new challenge regularly here on my YouTube channel. Each video will follow the same format. I'll explain the challenge and then it's your turn to code it yourself. In the last part of the video, I'll walk you through my own solution. And if you get stuck, that's okay. There are no prizes or winners, but if you'd like to share your solutions, you can post them in the comments or tweet them to me using the hashtag FridaySwiftChallenge. I hope you'll enjoy these challenges and I look forward to seeing your solutions. This week's challenge is a bit of an odd one, but in a good way. It's called the Sum of Odd Numbers challenge and it goes like this. Create a function that takes in an array of integers and returns the sum of all odd numbers in the array. For example, if your input array is the following -2, 1, 3, 5, your function should return 9 since the odd numbers are 1, 3, and 5. And 1 plus 3 plus 5 is, well, 9. Remember, your function should work with any array of integers, not just the example above. The easiest way to check if a number is odd is to use the modulo operator, which returns the remainder of a division operation. If a number n is evenly divisible by 2, n mod 2 will evaluate to 0. On the other hand, if n is not evenly divisible by 2, n mod 2 will evaluate to 1, meaning that the number is odd. For example, 3 mod 2 is 1 because 3 divided by 2 has a remainder of 1. But 4 mod 2 is 0 since the remainder of 4 divided by 2 is 0. You can use this knowledge to finish the challenge. There are also other, more sophisticated ways to check if a number is odd. I'll show you one such method in my solution. But first, try to come up with a solution on your own. Pause the video and give it a try. And when you're ready, we'll walk through my solution. Good luck! Welcome back! How did you do? Now, let me show you my solution. First, I'll declare a function and name it SumOdd. It takes in an array of integers as a parameter and returns an integer. I'll declare a new variable called result and initialize it to 0. This represents the final sum that will be returned. Now I'll use a for loop to iterate through the numbers in the array. For each number, I'll use the modulo operator to check if it's odd. If the result is 1, that means the number is odd and I'll add it to the running total. When the for loop is finished, I'll return the result. And that's it. Let's try it out. If I input the array of numbers 1, 2, 3, the output should be 4 since we've got two odd numbers, 1 and 3, that add up to 4. Let's see if that's the case. The output is 4 just as we expected. And if I input the array of numbers -2, 1, 3, 5, 7, the function should return 16 because the sum of the odd numbers is 1 plus 3 plus 5 plus 7, which is 16. Awesome! Now, there's another way to check if a number is odd that's a bit more sophisticated. Instead of using the modulo operator, we can use the Bitwise XOR operator. The main idea behind this approach is that the last bit of an odd number is always 1, while the last bit of an even number, 0. For example, if we take the number 12, its binary representation is 1100. 12 is an even number, so its last bit is 0. On the other hand, if we pick an odd number, say 11, and check its binary representation, which is 1011, we'll see that the last bit is 1. Now comes the interesting part. If we XOR a number by 1, its last bit will be flipped. If the last bit is set, which is the case for odd numbers, XOR by 1 will turn the last bit to 0, decreasing the number by 1. However, if the last bit is not set, XOR by 1 will set it to 1. Thus, it increments the number. So, if we XOR an odd number by 1, the result will be equal to its decremented value. I'll show you what I mean through an example. Take the number 3. Its binary representation is 0011, or simply 11. 3 XOR 1 equals 2, and as we can see, the result is indeed equal to 3 decremented by 1. Now let's see how we can use this in our code. I'll change the condition if n modulo 2 equals 1 to if n XOR 1 equals n minus 1. And the function should work exactly the same. Yep, same results. There you have it. These were two different ways of checking if a number is odd. But why do we need to know this? The answer: performance. The bitwise operators are actually faster than the normal arithmetic operators like the modulo operator. So if you need to optimize your code for performance, then using bitwise operators would be a good idea. Although it doesn't really make a difference in this case, imagine if we had to sum up 1,000,000 numbers. In this case, the difference in performance would be quite significant. And by the way, if you're interested in learning more about code optimization, algorithms, and data structures, I suggest you check out my course on Udemy, Introduction to Algorithms and Data Structures in Swift 5. I hope you've enjoyed this challenge and learned something new along the way. Thanks for watching, and I'll see you next time for another Friday Swift Code challenge.